Alright, so let's go through the light summary. Okay, so light, basically we have learned about two concepts, the two very important concepts. The first concept will be called the reflection, right? Okay, so we learn this reflection. So there are two types of reflection. Okay, the first type that we are more interested in is the regular reflection. So regular reflection is like this. Okay, so regular reflection means the light will bounce off a very smooth surface in a parallel configuration. Okay, so regular. Yeah, so if I have this surface, right, very smooth surface, this light ray will get reflected parallel. And this regular reflection, we can see our own image. Okay, the second type of reflection is called the diffuse. Okay, diffuse refraction. So diffuse refraction is where the light bounces off from a very rough surface. Right. So example is your, let's just say I draw a rough surface. Example is your like a stable surface or even your wall surface. Okay, I draw a normal. Okay, so you can see that the light rays do not reflect in a parallel fashion. Okay, and we need to know the two laws of refraction. Okay, the first law is that the angle of incidence is equal to the angle of reflection. This one is the simplest one. The second will be that the incident ray, okay, reflected ray, and the normal, okay, all lies in the same plane. So just remember, normal is something like a perpendicular like that. Okay, so whenever we are drawing the reflection or the refraction, we always draw a dotted line. Okay, and this dotted line must always be perpendicular to the surface. That's why it's called normal. Alright, so yeah, so these are the two laws of reflection. Okay, so let's go back to our regular reflection. When we see our own image in a mirror, the image has 5 characteristics. Okay, so the 5 characteristics of a image inside a regular reflection. So let's go regular, right? So the five image is the first will be definitely virtual. Okay, second will be same size. Okay, third will be object distance equal to image distance. The fourth will be your laterally inverted. Okay, and the last but not least, the fifth will be your upright. So if you are standing upright, definitely you will see image that is upright. Okay, so these are the 5 characteristics that we must memorize. So yeah, so you can memorize by VS flu. VS flu. VS flu. Alright. So yeah, so this is the regular reflection. And if I go back to the angle of incidence equal to angle of reflection, just to re-emphasize, okay. So the angle incidence equal to angle of reflection also takes place inside a diffuse reflection. Okay, although the reflection is diffuse, but nevertheless the angle of incidence is still equal to the angle of reflection. Okay, so this one still applies. Alright, okay, so let's learn how to draw our reflection diagram. Okay, the ray diagram for reflection, because sometimes you might need to know how to draw. Okay. Alright, so if you look at this diagram, so this diagram, let me just zoom in. So we have of course a object and a observer, right? Where the observer, the eyes is there. Okay, so first of all, whenever we draw a ray diagram, we must always draw a so-called image right here. Okay, image, and draw a dotted line from the object to the image. Okay, then of course you draw a two light ray from the object and draw a normal. Draw two normals right here. Okay, so last but not least, you draw a two dotted line from the image. So draw two dotted line and make sure that the two dotted lines are straight line with these two lines. Okay, so make sure they are a straight line. Alright, so now we have completed our ray diagram. Alright, so why do I draw dotted line from on the right hand side of the mirror? Because remember, our image is actually a virtual image. That's why I draw anything that is not real, I draw dotted line. Okay, so this is reflection. Okay, the next will be the more important one, which is called the refraction. Refraction is the bending of light, right? Okay, if you still remember, it's the bending of our light. Okay, so why does my light bend? Because of the change in speed of light. Okay, change in speed. So speed, I just put this of light. So when does the change in speed occur? When it is traveling from air to glass or air to water. Basically in a denser medium like our glass prism or even our water, right, the light will the speed of light will decrease. Okay, so imagine I have a light ray in this particular manner, then I enter a glass block. So you notice one thing is that the so-called the light ray will bend towards the normal. Okay, so the speed will means that the speed of light decreases. And how do I calculate the refractive index of a glass block? Very simple. You simply just use sine I over sine R. The I is the angle of incidence, and the R is your angle of refraction. Okay, yeah. So we need these two parameters in order to calculate my refractive index. The other formula that we can also calculate the refractive index of the glass block is speed of light in vacuum divided by the speed of light in glass. Okay, so normally the speed of light in vacuum is, we call it C. It's a constant, which is equal to 3 times 10 to the power of 8 meter per second. Okay, then of course divided by the speed of light in glass, which is a lower value, V. Okay, and for the refractive index, you must always get something bigger than 1. If you get something lesser than 1, means that there will be some calculation mistake. Alright, okay, and yeah, so this is our refraction. Okay, next will be the critical angle. So what is critical angle? Okay, if I draw some like a glass block, and I draw a normal. Okay, so the light ray will travel from the glass block into the air. Okay, when my light ray has a angle of refraction of 90 degree, means that this is the angle, this is a critical angle that we are talking about. And if I increase the angle of, if I increase the so-called incident ray, it will get reflected. Okay, so this is what we call the total internal reflection. So in order for total internal reflection to take place, first of all, there are two criteria. First is that it must travel from more dense to less dense medium. So I must travel from glass to air. Next will be the angle of incidence must be greater than the angle of than the critical angle. Okay, yeah. So the angle of incidence they are referring to is this angle. Okay, so let's draw a normal. So this is angle of incidence. Yeah. So as long as my angle of incidence is greater than my critical angle, the light will get reflected in this particular manner. Okay. If my angle of incidence is exactly equal to the critical angle, means that my light ray will just travel on the boundary of the glass block, like this. Okay. Yeah. So this is for your total internal reflection. And for the critical angle, definitely we can calculate critical angle for every different medium. So glass has its own critical angle, water has its own critical angle, oil has its own critical angle also. Okay, so the formula is sin C equal to 1 over n. So you want to find your C, right, which is the critical angle. So please do not mix up the C and the speed of light. Okay, so this C is the critical angle. So C is equal to sine inverse 1 over n. Alright? Yeah. Okay, so actually for the critical angle, it is derived from our this n equal to sine I over sine R. Alright, so let me show you how do I derive it. Okay, so first of all, we must know that for the angle of incidence, actually they are referring to the angle that is in the less dense medium. So they define that the angle of incidence, let me just go here, the angle of incidence is actually in the less dense medium. Okay, and the angle of refraction is in the more dense or the denser medium. Okay, so for example, if I draw a glass block right here and I draw a normal, okay, the light ray might be traveling from the glass, so I come out from the glass. Okay, and most of the students will say, hey, this is the angle of incidence. This is not true, because although we know that the light is incident on the glass block, but that does not mean that this is the angle of incidence, because the angle of incidence is always in the less dense medium. Okay, so in this particular manner, let's just say I refract away, right? Refract away from the normal. This will be my angle of incidence, and this will be my angle of refraction. So that's how they define the I and R in the refraction context. Okay, so yeah, so just think of this, and if I use n equal to sine I over sine R, how do I get my critical angle? Okay, very simple. If your angle of refraction is equal to equal to the critical angle, means that the light ray will travel in this particular manner. Okay, and this is what we call the angle of incidence. Okay, and this angle of incidence is equal to 90 degrees because you travel on the boundary of the glass surface. So I just simply sub n sine 90 divided by sine I will give me my n. And they define that the angle R when the I is 90 is equal to the critical angle. So I simply just change the symbol R to C. Alright, then after that I manipulate my equation a bit. Sine C equal to, so sine 90 degree over n. And sine 90 itself is actually equal to 1. Yeah, this one you can press calculator. Yeah, so basically for critical angle, it is being derived from our n equal to sine over sine C. Alright? Okay. Alright, okay, so of course, total internal reflection, there's application. This application is actually very important. It's called optical fiber. This optical fiber is to transmit it's like for telecommunication. Okay. So the reason why we have Wi-Fi at our house is because there is an optical fiber. Optical fiber to transmit the information from the power, from the so-called the center, right, the source, to our house. Alright, and optical fiber is made of two materials. Okay, so two materials. So inside is made of one material, outside is made of another material. Okay, so if you look at here, the yellow color is the information that is being transmitted. Information is like your light. Light can also contain information. Basically, it's your electromagnetic radiation that contain information. So the whatever that's inside the optical fiber is made of something of a higher refractive index. Okay, and whatever that is outside of the optical fiber is made of lower refractive index. This is because remember your two criteria for total internal reflection. The information or the light must travel from denser medium to less dense medium. So the material inside must be made of higher refractive index for the so-called information to undergo total internal reflection. Okay, so yeah, so just think of this. And why do we not use copper wire to transmit the information? Very simple, because optical fiber will cause less information loss. Okay, so less information loss means that the information that from the center to my house, right, I can get most of the information out, instead of like just get partial information from the signal, right? So yeah, so basically this is the summary for our light.